Okay, 3-5 symmetry. So a figure has symmetry. It's not catching up.
Just go.
No, I can't. It's like messing me up when I'm writing. It's weird. Okay, a figure has symmetry if a rigid motion can be mapped. So translate could not map something onto itself, can it? No. Nope. We had reflect. Can we reflect something onto itself? Yeah. We had rotate. Can that rotate onto itself? Mm-hmm. Yeah. Okay. So a line of reflection for a reflection symmetry is called the line of symmetry. See, now it's caught up. So we have vertical lines, we have horizontal lines. Is there anything that says we couldn't have a diagonal line?
Nope.
Nope, nothing. Does that work if I do a diagonal on that?
Yeah.
You think?
No.
Because it'd be like a rectangular piece of paper, right?
Oh yeah.
And if I took the two, would that work?
No.
Stop.
Yeah.
Really?
I wasn't looking at the shape.
work.
No, that would not work.
Hey, do that and then cut it down the line.
Okay, well that's not what we're doing. Okay, we can have diagonal lines of symmetry, but these two this shape does not have it. Okay. A figure has rotational symmetry if its image can be mapped onto the pre-image after a rotation of less than 180 degrees. Or equal to. I think that word's missing. Because 180 degrees is fair. So the shape we had before is here again. I have the point of rotation is in the center. And I need to rotate this point until it gets back to the same exact shape.
Okay.
So could I do it after 90? Stopped right here? No.
No.
Could I do it after 180?
No.
Yeah. Well, if I took it, it would, like this would go here. Does that make sense what I'm saying?
Yeah, but
Okay. Let me do it other than the point. So if I took this shape, and we're talking like here, if I move it 90, it's going to be standing up on end. Yes? If I move it 180, is it going to go right back to where it was? Yes. Okay. So we have a rotation of 180 about point P. Okay, it says identify the lines of symmetry. How many lines of symmetry does this rectangular hexagon have? So I can put them through all the midpoints. So the midpoints would be 1, 2,
4.
3.
Hey, I said that.
Okay. I also can put
You
them.
can do more.
I'm getting there.
The middle.
I could also do the vertices. Yes.
Yeah.
1, 2, 3.
Yeah.
Anything else? I don't think so. So how many lines of symmetry are there?
7.
6. 1, 2, 3, 4, 5, 6. Why can't I go to 7?
Oh, because you're
No,
Because you're can't counting the same line. Did you guys draw yours in? Okay, how many lines of symmetry does each figure have? How do you know whether you have found them all? So I'm going to pick on Regan. This rectangle, how many lines of symmetry do you think it has? 2. Where are they at?
And then like
Horizontal, vertical.
horizontal and then vertical.
Horizontal is 1, and vertical is 1. How do I know if I have all of them done?
Fold your.
Fold your paper in your mind, right? Can I do this?
Yeah.
No. It did not fold itself on top of, right? So we have 2.
Yeah.
So
Oh,
2.
this one couldn't work.
Okay.
That's just
Noah, the plus sign. How many we got? Where are they?
Hard. I'm sorry.
Horizontal, vertical, diagonal from vertices. What do we got?
what?
Come on, Noah.
Noah.
Where can I fold this?
Across. This.
Horizontally.
Yeah.
Okay. Anything else?
Could you vertical?
I could vertically.
Holy crap, Whitman.
This one.
Okay, Sarah. How about this next one?
1.
1. Where at?
The down the middle.
Vertically?
Yeah.
Why not horizontally?
Because of the
Yeah, the top's smaller than the bottom, right? Why not diagonally?
because it doesn't match.
Doesn't match.
Yeah.
And I can test it out. That's all I need to do, right? Dakota. The smiley face.
Oh, there we go.
What?
Horizontal.
Horizontal?
Huh.
If I fold that horizontally, it's going to map exactly onto itself.
No.
Only vertical.
I think it would be vertical, yes? Now, without the smiley face, would this be infinitely many lines of symmetry?
Yes.
Yeah. But the smiley face messes us up, doesn't it?
Yes.
So I have how many?
Darn swim.
1.
1. So 2, 1, and 1.
Darn that smiley face.
Okay. Identifying rotational symmetry. So, rotational symmetry is what angle of rotation does a figure map onto itself? And we will be talking to about all of them. So, this B would move to A, yes?
Yeah.
And it'd be the same. Could it also move to C?
Yeah.
Yep. So, in one whole circle, how many degrees do I have?
360.
360 divided by how many points on this shape do I have? 3. So 120
Yeah.
is my rotational symmetry. Okay? So 120 gets B to A. What gets B to C?
120.
Nope.
Oh, B to C.
All the way
80.
240.
You really expect us to know that?
Well, I would expect you to be able to add 120 plus 120.
Oh, I wasn't even looking at the board.
Okay, so the rotational symmetry here is 120 and 240. I don't go the next one. What would be the next one? 360, because 360, did it move? No. So it's 120 and 240. Okay, a parallelogram. Now this one says it's going clockwise, but it really doesn't matter. I'm going to turn it and get it right back to itself. How much am I going to have to turn it?
180.
No.
Well, 90 would be here. I need to go to 180.
I'm pretty sure that's
Okay.
what I said.
It is. And 180 is it. I stop because 180 plus 180 is 360. Okay, so I have an hexagon and I'm moving this point right here. I can move it once, twice, 3 times, 4 times, 5 times. Yes? How many vertices do I have on this? 6?
Yes.
So 360 divided by 6 is what?
60.
60. So 60 degrees is the first rotation. The next rotation would be what?
120.
120.
180.
And then 180.
240.
240.
300.
300. And do I stop?
One more.
Nope. One more gets us back to 360 and we don't do 360. Okay. So our star, how many points, like how many points do I have on it? 4? Yes? So 360 divided by 4 is what? 90?
90.
So 90, and then the next one would be what?
180,
180. And then
270,
270, and I stop. Because the next one is what?
360.
360. Now we have an oval. This oval actually has 1, 2 lines of symmetry, yes?
Yeah.
But does it have rotational symmetry also?
No. Yeah.
No. Yes.
What about 180?
Yes.
If I did it 180 degrees, would it go back on itself?
Yes.
Yes. Okay, the last one we have, it says determine the symmetry, what types, and then we would classify it. So we have rotational or reflexive, yes? So this flower, does it have rotational, reflexive, or both?
Both.
Both. How many lines of symmetry does it have?
5.
5. So we're going to say reflexive. Five lines of symmetry. And rotational. By what degrees? Well, how many points do I have on this flower?
5.
I have 5. So 360 divided by 5. So 5 goes into 36. How many times?
6.
7
72 degrees.
with a 1. So 72 degrees. And
144.
144. And
216.
yep. Another one?
288.
288. Another one? 360. So is there another one?
No.
No. All we did was found the first one and kept adding, right? And you stop before you get to what? 360. Okay. The next one. Rotational or reflexive? Or both?
Rotational.
Okay, rotational. I heard that more than once. By what? How much?
180.
180. So it's rotational. $180 because you got to get this red dot back over to the other side, right?
Yeah.
Okay. So does it have reflexive?
No.
No.
What's messing up any reflexive hopes?
The dot.
The 2 red dots. Because if I did this, would I be off on the dots?
Yeah.
Yep. What about this? Would I be off?
Yep.
Now, it's a rectangle, so obviously nothing through the vertices, right? But those 2 red dots mess us up. So when there's something on the picture, do we need to look at it and pay attention? Yes. Okay, so that is all I have. I have a worksheet for you, and then when you finish the worksheet, I want you to go on and do the Math Excel for tomorrow. Because when's your test?
Is it that golf thing?
Thursday. No.
Yeah, you saw